Okay, here we go. So today's lesson is all about what we call special factors. Special factors. Now, these are not on the... Actually, one of these is on the factoring flowchart, but the first one we're talking about, these are just special cases that we have to learn about here. Okay? So the first one is called the difference of two squares. When you see the word difference, what does this word mean, difference? Subtraction. Good. Okay, so that's subtraction. Two, of course, is there's just two things, right? And then squares. Can you give me like a number that's a square? What's a number that's a square? Like, yeah, 4 is a square. Give me another number. 17 is not a square. 14 is not a square either. 6 is not a square either. 25 is. Give me another one that's a square. 49 is good. Give me another one. 9. Give me another one. 81. Give me another one. 36. Yes. 100. Good. Okay. So, all right. You guys got it. Good. So the question is, hey guys, chill out. Guys. All right, you guys ready to go? Okay. A little rough start there. So, a special case is when we're going to have a subtraction sign between two of these perfect squares here. Two of these things that are squared. That's a special case. So, in general, it's going to look something like this. You're going to have the first number is going to be squared. There has to be a subtraction sign between them. And the second number has to be squared. The A and the B have to be numbers that produce squares. Okay? And sometimes they will be squared and sometimes they won't. But whenever you have the difference of two squares, it automatically factors to whatever A is plus B and whatever A is minus B. This is the general rule right here. So this is the thing that we're going to follow. So we need to look for a subtraction sign. This should be a B. A subtraction sign, two numbers that give you squares. That's what this means right here, difference of two squares. So here is the difference part. There's the difference of two. I got an A and I have a B, and they are squared. That's why we call it the difference of two squares. Does that make sense? So the name implies exactly what it is that you're doing. Okay? The name implies exactly what it is that you're doing. So as an example, I will show you right now. Let's say I try to factor 9x squared minus 4. 9x squared minus 4. Okay, first of all, ask yourself this. Is there a subtraction sign here? So that's the difference part. Are there two numbers that are perfect squares? Yes, a 9 and a 4. Well, then I know I'm dealing with the difference of two squares. It will always factor to whatever A is. Now, what number do you have to square to get 9? 3. So that's going to be a 3x and a 3x. That's the A part. And what number do you have to square to get 4? 2. So it's going to be plus 2 and minus 2. And that's the answer. I know, right? Pretty sweet, right? That is... Alright, examples we're going to factor. And the first one that we're going to factor together is a very basic one, number 1. It's going to be x squared minus 81. X squared minus 81. Okay, first of all, is this a... Can you factor out the greatest common factor? No. Besides 1, there's no greatest common factor. Okay, next. Is this a binomial? Yes, it is. Follow on the flowchart. Is it a binomial? Is it in the form of a squared minus b squared? Yes, it is. So what you want to do is you want to figure out, okay, what is being squared here? A squared minus b squared. We want to figure out the a and the b. So the a, in this particular case, the thing that's being squared is x. So I always write it as x quantity squared minus what is being squared here to get 81? 9. So that's going to be 9 quantity squared. So the x part is going to represent the a, and the 9 part is going to represent the b. So that is always going to factor to, remember, a squared minus b squared always is a plus b times a minus b. So I'm going to have an x plus, what's the b, guys? 9, and an x minus 9, and you're done. That's it. What do you guys think? That's pretty easy, huh? Okay, number 2. What if I give you this? 16x squared minus 9. We're going to factor this. Okay? First, what number are you squaring all right here? What number are you squaring? What number do I square to get 16x squared? 4x. This is the part that everybody doesn't see, that it's a 4x all squared. Because 4 squared is 16 and x squared is x squared. Minus, what number do I square here to get 9? 3 squared. So the a part is going to be the 4x, and the b part is going to be the 3. So what is my answer going to factor to? 4x minus 3 and 4x plus 3. Very good. Very good. All right, so looks like you guys are catching on. Let's do the third one here. What if we did, let's do a squared minus 25b squared. Let's do a squared minus 25b squared. Okay, ask yourself, is there a minus sign? Is this two things being squared? Yes, so let's figure out this part and let's figure out this part. What am I squaring to get a squared here? A, yeah, I just a and then I put parentheses to get squared. What number do I need to square to get 25? 5, and then I need to square the b, so 5b all squared. So that part is the a, and that part is the b. So what's my answer going to be? A minus 5b and a plus 5b. Very good. All right. Try this one. Number 4. What if I gave you this? What if I gave you 4 minus 16n squared? All right. What number do you need to square to get 4? So 2, quantity all squared, minus what number do you need to square to get 16n squared? 4n. Very good. All squared. So what's the answer going to be? 2 minus 4n and then 2 plus 4n. Now, technically, we could have gone about this another way, right? Yeah, actually, because this part, the very first thing that we have to do is, on the factoring flowchart, is factor out the greatest common factor. And is there a greatest common factor here? Yeah. There is. What is it? It's 4. So I would factor out a 4, and I would have a 1 minus 4n squared. See that? Yeah? So this is still the difference of 2 squares. So I'd have a 4, and then I would have 1 squared minus 2n squared. So it's the same, it's a problem that's inside here. That's the part, that's the difference of 2 squares. So that would factor to 4 times 1 minus 2n times 1 plus 2n, and that's the final answer that we want. So don't forget to always factor out the greatest common factor, otherwise you're going to get a different answer than everybody else. Alright, this one is a little bit more interesting, and perfect square trinomial, so we know that, what does the word trinomial mean over here? Yeah, we're going to have 3 terms here, okay? And we're going to have some kind of a perfect square somewhere in that 3 terms. So I'm going to give you the general rules, and then we'll do some, talk about it. So here's the general rule. If you have a squared plus 2ab plus b squared, it will factor to the quantity a plus b all squared. And if you have a squared minus 2ab plus b squared, it will always factor to a minus b quantity squared. So here's the general rules. Now, why do they call this a perfect square? Well, a couple of reasons, okay? The first one is, you'll notice that this is a perfect square, this is a perfect square, correct? The 2 pieces on the end, they're perfect squares. And the piece in the middle is twice a and b put together. That gives you your perfect square trinomial. Alright, so let me give you some examples for this. This one's a little bit more tricky. And once you see a few of them, you'll start to understand. So if I have x squared minus 16x plus 64. Alright? This is a trinomial, right? And do you notice that the first thing is x quantity squared, yeah? And you notice the last number is 8 quantity squared. Is that true? Okay. Then if I multiply a negative 2 times x times 8, do I get negative 16x? Yes, I do. So that means that this will automatically factor to x minus 8 all squared. Now, you don't have to do it that way. You really don't have to do it that way. You could always have just done a diamond problem and gone 64, negative 16, positive and negative, right? That means that they both have to be negative. And what two numbers make it work? 8. 8 and an 8. So you would just write down x minus 8 and then an x minus 8. But how many of these do you have? You have 2 of them. That's why this is squared there. So that's x minus 8 all squared. So to me, you guys, it doesn't matter which way you do it. Some students really like the perfect square trinomial, and some students really just like the diamond problem. It does not matter to me. I just want to introduce you to these things, okay? So let me give you another example. What if we did, here's where it comes in handy. Okay, let me give you one where it comes in handy. Like 4x squared minus 12y plus 9. Right? 4x squared minus 12y plus 9. Well, I noticed that this piece right here, that's a perfect square. That's 2x squared. This piece right here, I noticed that that's 3 squared. And if I multiply 2 times 2x times 3, notice I get my 12, oh, this is an x, by the way, 12x. So therefore, I know the answer has to be 2x minus 3 all squared. Now, that comes in handy, right? You don't have to do it that way. We could have done it the other way, where we would have done the 4 times the 9, and we would have got x squared minus 12x, what's that, 36, right? And then we would have done our diamond problem. We would have done 36 and negative 12. What two answers make it work? Negative 6 and a positive 6? No, 2 negative 6s, right? Isn't that what it is? Okay, good. So now right back, I'd go 4x squared minus 6x, and then what? Plus 36, yeah? And then I would have grouped those two, I would have grouped these two. And then I would have had a 2x, and I would have left over a 2x minus a 3. And then I would have had a negative 3, and then a 2x minus a 3. And look, you get the same thing. 2x minus 3 times 2x minus 3, which is the same thing as 2x minus 3 all squared. So it doesn't matter to me which way you guys want to do it. I just want to introduce it to you. The more important one, I think, for now, for you guys, is the difference of two squares. This one, okay? I'll put this back down for you. All right, so, but it doesn't matter to me which way you ever want to do it. So we have two new special products today. They are the difference of two squares and